So how do we do these in code? Is there going to be some help for us, I wonder? Talk about native here. Blueprint behavior to native behavior tree services. That's just for the song. Yeah, it says the same with tasks as well. So, okay, native behavior tree tasks, I guess we want to look for. Let's see if the Unreal page has anything about it first. Quick start. Let's look in the CPP. I think this might actually. Sorry, randomly half singing some stuff as well. Hi, Kenota. Not so much learning blueprints. Now, I'm quite happy with how blueprints work. We're more trying to learn how AI behavior trees work in Unreal. We've created one of these in CPP. Sorry, in this kind of graph view, and you make these tasks. Let's look at like this task, for example. We made this via the blueprint system, and I want to learn how can we make these as CPP classes instead. So, I mean, we quite often, if we're making a CPP class, you can sometimes we go here. We don't have anything in here, so we go new. Let's look for a task. Okay, what our search results were showing us. So it's a U object is a BT task, BT service, blueprint base. We don't want blueprint base. Behavior tree can. Still though. So it's a UB task node you can make. And the blueprint one will just expose out those things, I'd imagine, right? My goal is to learn how it works rather than to like make a game. These whole things are about like exploring different areas of game development. So we've looked at things like shaders and materials. We've had a look at particle systems. We've had a look at creating a character and importing it into the engine. So yeah, we're just looking at different aspects, and so it's really about trying to learn it. The underscore. Yeah, no, it's easier to read. I think it's easier to read. It's not that confusing, but okay. So we have these functions. Okay, so let's have a look at task node. Tasks are leave no behavior, partial actions. The instance of specific following virtual functions are not marked as const. Okay, so you have a node memory block where you can write stuff to. It seems to, right? You don't change. So these nodes, it's like a static by the sounds of it. It's every time you use one of these nodes, it's shared information between. So you don't want to be writing anything to the actual class. I think. I've already made that, you just don't know it, crew. This is just a facade. I'm gonna guess we make one off of that. And let's not give it let's call it BT task node. So you've already made a task, but we used underscore. I don't know if we'll use an underscore this time. So this one, we're going to try and imitate the, what task did we have? Get random location. Find target actor location. That one, for example. Oh. Let's just create this and see what happens, shall we? I agree. See, completely with you, Kanota. Now I find it fine to read, but it used to be very like confusing to look at a glance. But some of it, a lot of things that are confusing are really not. Once you know what they are, it's fine, and that gets rid of a lot of the kind of confusion. So all of the colons you see everywhere, that always used to confuse me. Crew Castle. Okay, while we're waiting for this class to create, let's have a look online to see if we can find a bit of a guide. So creating custom behavior tree tasks in native or native CPP UE4. I kind of don't want to use all of this. Is like, it never shows you the code, it shows you the bloody blueprint stuff. So they have a lot of docs about it, but I just want to look at something that isn't. Oh crikey, we're struggling here, aren't we? What was the name of the subclass we made? It's fine. Check that. Let's open up. Have to compile. You don't understand it, the Blackboard. What are you trying to get it to do at the moment, Brain? We find project. It's Unreal repos. Yeah. That is what we want to open. Why is it opening a different instance of Unreal? I've already. It's cool to see you're still active. I wish you all the best in your endeavors for the perfect AI. Oh, that's nice of you to say, Crew Council. Yeah, normally we don't stream midweek. I was meant to stream on Sunday, but I postponed it, so that's why we're doing this now instead. It's nice to see you briefly, though. I hope you're keeping well. Oh, did you say what your card game was, by the way? Think what? Not. That's okay. Share ideas will only steal them. Okay, so if we go into source, we should have our yes, there. That's what we're looking for. This. It has nothing at the moment. It inherits from this, which is how we saw that comment earlier, right? So what have we got in here? Execute tasks. Starts this task. Should return succeed, failed, or in progress. So we can essentially like set up an event, bind to something, wait for a callback from it. Yeah. I imagine that everything goes out of scope in the task. And oh, actually, yeah, it says you're not taught to stuff as well within the class. There must be some flipping guides on this stuff. Task aborted. Task should return aborted. State of that object. No, it is not instanced. We don't. It is said earlier. There's no memory. We can use. This is a pointer to a uint 8, which is our memory. And here's the brain component as well. The brain will be Blackboard, I believe. I've seen little bits of these before, but I don't really know. No memory could be values that we pass in actually. So you know when we look at where's our behavior tree? Still got it in a different window. Yeah, you want to show me and pick my brain node? Of course you can. You're welcome to give me a call, brain, and we'll have a look at your problem. Try and work through it. What I was saying about the task is it could be these where we set up the node memory here. Should probably. All right, let me take this call from the wonderful, the beautiful, the talented, the charming Brainoid Games, everybody. I'm sorry, I'm just plugging in headphones quickly and then I'll press play. Hello, Brainoid.
Say hey.
Hey.
Okay.
Hello.
Hi.
Hi.
Where is the share screen thingy? Okay.
Have a butcher's hook. Pop out.
Yeah, so you see this?
I got you. Yes, I can see your level.
So I made this. I click here and this character moves.
Diablo.
Where I click? Yeah, Diablo actually, like because when I hold it, it
Oh,
follows.
okay. Very Diablo.
Very Diablo it is. Oh.
Hey, partly, by the way, welcome to chat. Carry on, dude.
Okay. Simply, this is working. So wander around, and I have I haven't tested yet. I was working on this, and runaway thing was working, but so I added the spawn sensing on this one.
Okay.
And I have this perception.
Good. Yes, I remember you had to have that. So if you want them to be sensed, they need to have that component in it.
AI sense sight.
Okay.
Is added as a source. Okay.
And that array exists on the other thing as well, doesn't it? Thank you. I remember there was an array you had to set up on the actual thing. Where is it at?
Sure, because it works right now. Maybe it's something to do with tags.
There wasn't. I swear. Do you remember?
Yes, I remember something like that, but I'm not sure because it works right now.
Try going into the blueprint of it.
Blueprint of this one?
Rather than the instance, yeah. Just to see if something else shows up in there, because it could only be.
Okay.
You click on the AI character. This. Actually, no, it could be in here.
Nothing different, I guess.
This is a video Discord call. It's both of them can order. Try clicking on the main character. I don't think it would be there.
What do you mean by the main character? This one?
Yeah. I don't think.
Sense.
No. I just remember there being a list, and it wasn't just on that stimuli.
But it works.
Hmm.
Look, so look here. So begin play. I have castings and stuff,
Yeah, yeah.
and then I bind on C pawn event. Actually, I could do this, but I realize it a little late. There's
Oh, they
something.
have an event in there already, do they?
Mm-hmm.
Okay.
As you can see also here, that they don't have a on lost pawn site or
Yeah,
anything.
yeah, okay.
Oh, that's very ridiculous. I'm not. I don't know. So okay, I have this event, and when it sees the pawn, it triggers this event, and it checks if this pawn is the player actor I'm controlling here. This one.
Yeah.
Okay. Where was it? Sorry. Okay. And if it's equal, I put it in a branch, and if it's true, it gets the AI controller and reaches the Blackboard and sets the bool value of player is seen.
Okay. Yeah.
Okay, and I do this retriggerable delay thing.
What's the
and set
retriggerable delay? I've not. I know a delay. That's a one-off. So that just means, hang on, late in action.
So when you trigger it again, it resets.
Ah,
This
right.
is of it. I
So if
think
it gets
that's.
called multiple times, it won't.
Oh, yeah, it says here, calling again while it is counting down will reset the countdown to
Yeah.
duration.
Okay, that's good. That's good.
This
Yeah,
looks
partly I agree.
legit, right? I guess. So
Yeah.
I will play this and show you something. So we need him to see us. Okay, it's in here. So let's see. It says player chart 2.
Mm-hmm.
See, it's called player chart 2. It's
You,
correct.
yeah. Was there a play child? No. Oh, that's the AI character. Okay, that's fine.
Both are AI characters actually, but
Yeah, yeah, yeah. It's just because they called player child. I got confused. There's not a
yeah,
problem. Carry on.
So I also have this player actor cached in player controller, and it's the same thing. So I'm
Yes. So you're double checking the so it should get past that equality check, right?
yes,
Okay.
and frame skip. So it's true. Goes in the Blackboard, and also let's check this, the return value.
Yeah.
BP AI controller C0,
Yeah. 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 That's no good.
and let's
Can
go
we check
check.
you got those the words are correct as well in the Blackboard? Yeah. Can you switch to Blackboard for me as well to see your variable name? Oh, you can see them on the right anyway. But yeah, player is seen. Player is closed. Okay.
I'm using player is seen, and it is false right now.
Mm-hmm.
And where was I? Sorry, this one.
Right.
So
This
it
should
should
set to
stay
true.
here.
When I see
Yeah,
the
let's
key, a player is seen. Go back up on the just up a little the key that you've written in. Okay. Yeah, that's fine.
frame skip. Okay, it should have been set.
Go have a look, shall we?
No.
Hmm. Try
This I.
going. Oh no no no, that is up to date, isn't it? Because the position's really weird. Hmm. Where are we at? We're in the character, right? Yeah. So you should be able to set things here. You don't need to do like the key thing. This is the way that we set them.
For Watch Dogs. Yeah, it is indeed partly.
Okay. Yeah. So is that the issue at the moment?
Yes.
Yeah. Okay. Go back.
Blackboard doesn't work.
Go back a little bit.
Go
So
back
what's
where?
yeah?
To the Blackboard?
Actually, no. It's weird. It's not even to do with the logic, is it? Because like you're getting to that node, and you're
Yeah,
manually
everything
setting it, so
works
it doesn't matter what
perfectly.
happens before it. As long as you got there, it doesn't matter.
I mean, I can't see what's happening inside this. Maybe something wrong
What
inside.
sets it false? Oh, it doesn't. It sets it false after half a second delay, right?
Yeah, so we're still not there because like frame skip, frame skip, frame skip. See,
Oh
it's
yeah,
still
yeah, yeah.
we're not
What about
here.
at this point? Can you just double check the thing again for me? Yeah. What's the
So,
top? You've got current and saved.
I mean, the current is the current situation, I guess. Like, oh, it's true here now.
What does saved mean? Yeah, that's what I'm trying to. I don't even know, but okay. What about if you go back into the behavior tree?
Maybe that was the issue. Okay, it's true now here.
So it just needed refreshing.
Ah, really? This is so bad.
Fresh. There you go. But a little cheeky F5, right?
I had to do this three
Yeah.
times or something, maybe.
Well, why not? Why didn't you think of doing that? Silly.
Okay. Uh,
Okay, that's
let's
good. Seems like it's.
call it a night then.
Yeah, but I mean, it looks like it. That's good. It seems like it's working. At least, well, you figured out what you're doing was working. Is the behavior doing what you think it should do?
What's left is to get it properly working in the behavior tree now. So if we don't see the player and if the player is not close, we just go random places.
Yeah.
And then if we saw the player or players close, I'm not sure about this bit yet. Because I had this players close thing, then I added the pawn sensing. Now I should actually remove this and
Yeah. Let the sensing
players
go.
close is basically hearing, right?
Well, you can add hearing onto the senses as well. So,
I mean,
if you add sound onto walking.
in the sense of like he hears your footsteps or something.
Yeah. Yeah.
Okay, whatever. So
Do you remember that whistle tutorial we watched?
I can't forget it. Yeah.
So Metal Gear Solid, I thought I was in it just for a moment.
Nothing interesting
Yeah.
here.
Must be in my imagination. I'll go back to my patrol.
Okay, I'll figure this out. Thanks.
No, it's all good. Do you have any idea how we go ahead and do it via code? The tasks. I'm trying to have a look. I'll move your screen off my screen, sorry, so you can do it.
I don't know really.
So I've extended from the right. I think it's from the task node. Some of this looks familiar. There's a thing called like the node memory and the brain comp. I've seen these in work and they use those. So I think I'm in the right area. Like because the blueprint one is just an extension of this with a bit more done to it, you know, to expose it out. I mean, we can have a look at maybe the blueprint one.
Well, so you're gonna wanna use the receive execute on AI thing, right?
Yeah, there's an execute task. Was there a receive? That's what I mean. I'm not in the base class. It doesn't seem to be there. So I might need to have a look how the BT task blueprint base. I mean, actually, we could have a look how the weight works as an example, perhaps.
Yeah, why not?
Because that's quite straightforward, right? It defaults the wait time to this. What have we got? We got an execute task. We have a memory, which I don't know what an FBT wait task. That must be a certain struct that we made.
Execute task could be it because
it's just a struct.
the event is called receive execute AI.
Yeah. So execute task is likely to be it. I'm just trying to work out what's happening then. So we make a custom struct which will define what we want to store in our local memory for this node. Yes. So we have a memory and we set that to. We cast our node memory to be that, by the looks of it. No, to be a pointer to that. So, yeah, okay. We're making a pointer to a struct out of our node memory that was passed in. My audio, I don't know. I've got a fan on. I'll turn that off. You could be getting a bit of. I've got Brainoid's audio coming through as well, but actually no, my OBS does seem to be jittering.
Oh.
When these, can you see how it kind of it's sticking sometimes? Well, I stopped doing it now, bloody thing, as I try and show you. No, it's not. Okay, fine. Well, it was just kind of sticking at times. I wonder if that was what it was. Keep me informed on it. I don't mind you complaining or giving feedback. Okay, let's just try and. This is good. I guess this is.
I'm actually curious if they have a like leave the or finish task.
They have a tick task and finish latent task.
Okay.
That's what they call to do it, it seems. So this is the constructor, effectively, where we set our defaults. This is our begin play of our task. And then if it's a one-off thing we want it to do, we would just return succeed immediately. But if we want to wait back for something to happen, we then define this tick task would happen. I guess whilst it's in progress, it will call tick task. Here we're just setting the remaining time based on some random deviation. That's fine. We don't care about that. So we tick it. We seem to get in the owner component, the node memory, and the delta time. That makes sense. So the node memory would be whatever we create here, I guess. I'm guessing basically this is a generic way of doing it through calling this thing node memory and just giving it its memory address effectively, right? And we're just saying, right, we'll give you a memory address of a struct where we're going to be storing ship, sorry. And then that is kind of saved out, I guess, because it's a pointer. It's almost like by reference in a way then, right? That when we pass this in later, we're just going to get the pointer back to what we created at the start. And whilst it exists in this node memory, it's not garbage collected, I'm going to assume. Tick task, is that off-brand TikTok? Oh, partly. Thank you. Thank you for the
Great.
the joke. Oh, it's a raid from Code Rushed. Hello there, Code Rushed. Welcome along. How you doing? I'm going to put my fan back on because it isn't impacting the audio, and I am getting warm. Okay, so then the tick task, I'm going to assume just happens naturally. And then...
You know what I'm afraid of?
Ghosts.
We use... No, we not the ghosts.
Okay.
It's called the Ghostbusters.
Yes, of course. What are you afraid of, Brainoid?
We're using Blackboard key selectors in tasks, and in the code they could go very ugly. Yeah,
that's kind of what I want to see though, is because I think in the code it'd be easier to do certain things.
You want to face your worst nightmares.
Yeah, I want to know how to do these in code. I do, because
yeah, definitely. I mean, it makes sense. It doesn't make sense to make do these in blueprints because like AI needs some powerful CPU usage.
Yeah, and you're right actually. I know for a fact in work they use Blackboard to store they're using Blackboard, they're using behavior trees, but they write all like most of their own tasks. And like I know I had a task before where I was changing something to do with one of the projectiles in the game, and it might have impacted how the AI used projectiles. And I said like, oh, I'll look into it to see, but because it was in this stuff, I couldn't really make much sense of it. So I basically was just like, I haven't done these tasks before. Does anyone else have an idea? And a mate who I work with was just like, oh yeah, I can have a note into it for you. So like, I feel it would be good for me personally. I know that's a bit selfish, but I also think, as you said, computationally, if you're going to be doing a proper game where your performances are concerned, then you do want to be doing these and your services via the code rather than...
Yeah, to be honest, this doesn't look so scary, but I mean, we won't be using that my memory thing a lot, but focus on the owner comp probably.
Well, the only thing is that I do feel we probably will need to use that my memory.
But like for 2 or 3 things, like
I'm just trying, like, how else can you get things out? Because the one thing they do say to do when I looked at the base class, dude, was is you can't change things in the execute task. You can't change the state of the class. You can't cache anything in that class. So if you want anything to exist from frame to frame, then you need to store it in my memory, I guess, right?
Yes. But that's what I'm saying. Like you'll get some object or a value from there and use it.
Right. Okay, I see what you're saying. Yeah. So okay, yeah. Well, I guess we can look at this one, and then what we can do is, because you're right, the weight doesn't write anything to a Blackboard. So it'd be interesting to look at another example of how they do it with something that writes to the Blackboard, such as the, I don't know if move target does, because you have to give that a target. You need to give that an input, don't you? The move target, the move to, sorry,
Yeah.
that node. So we can have a look at that too. But okay, let me just read through it. So we get our memory in and we convert it into the struct that we've got. We change the time in that memory, and then we check, is it time to expire, and then it finishes. If not, then that's great. I don't get static description. Oh, this is just, I guess this is for the debugging or showing tooltips in the editor, I guess. Yeah, don't worry about those.
The question is, can we reach the Blackboard using the behavior tree parameter you're getting from the execute task?
Yes, I think we can, and we're about to find out how. The behavior tree, but did you find that? Do you mean the owner comp? Oh,
Yeah.
this thing, yeah. Yes. Okay, so let's go and have a look at another one of these then. What have we got in here? Task Blackboard. Don't know what that does. Move to?
Yeah.
That you may use. Great, look, I'm figure it. Just fine. It's fine. Okay, so again, this is setting it up. Okay.
Blackboard key, add object filter.
What is a Blackboard key? That must just be something that's part of this, right? Like part of the parent class. We haven't defined it here, right? Unless there's a header, sorry, with a Blackboard key in here. No. So, oh, hang on, no, it can be. No. That makes me think that it's part of the. Oh, this comes from Blackboard base. And this has a Blackboard key selector.
Yes.
Yeah, so this is the bit where this yeah, this one I'm not too sure is a great idea to look at, because this is extending off of Blackboard. The task that then turns into a Blackboard base, which then goes into it. Which I don't know if this what Blackboard base is. Is that maybe a task that uses a Blackboard? So maybe it is. Maybe.
Maybe all tasks are using this Blackboard base to Blackboard keys.
Yeah, it could be like a task on its own could be without.
Even the C++ side is. Sorry.
Okay, how about we go just see what extends this.
This is not a good structure.
Not a good search.
It's very weird.
What's wrong with my search? I want to see anything that extends directly off of this, so we can see, is there subtasks that are just coming from Node rather than Blackboard base. So we can see Blackboard bases, blueprint bases, finish with result does. Gameplay task plus the make noise does. On action, play animation. Okay, so a lot of the base ones do, but
maybe think of it like this. Maybe if you're sure that you won't be using any Blackboard key selectors in your task, you're better off not using them.
yeah, yeah. If I guess if it's something where you don't need to look at use the Blackboard to do something, that's pretty much how I see it. You can have your memory during the task. That's different. But if you don't need to share information with the rest of the tree, because that's really what you're getting with the Blackboard, right? You shared memory between tasks that is persistent. Whereas this memory that we're using here is just during a singular task, and it'll go out of scope once the task is complete. Okay, the only ones that extend the Blackboard base are rotate to face Blackboard entry. Okay, that's a good one to look at, and the move to. Yeah, so I think you're right. If we have a Blackboard entry, if we're using the Blackboard, then we need to extend off of this Blackboard base one.
And I think the blueprint version is using the Blackboard base key no matter what.
Blueprint base. Extend. I just can. Blueprint base comes directly off of task node. Interestingly. Yeah, but it basically makes all of these blueprint implementable events, right?
Yes.
And then when do we call, for example, receive execute? When is it called in the CPP of it? Check.
Probably behavior tree triggers it.
Oh, with the base one, you mean? Or
Behavior trees execute.
oh, the whole tree that is executing the nodes. Yeah.
Sequences.
Sorry, can you say that again?
Probably a sequence from the behavior trees triggering them.
Yes. Yeah. That's fair. It will get this, and it will call this node on it, this function on it. Okay. Let's go back to this one. Let's rotate then.
Don't get lost.
How did they do that? Well, I mean, would base for because they extend from this, right? So let's just have a look. What do they initialize from asset? We have a behavior tree. We have a get selected Blackboard key, and we have a selected key, Blackboard key selector. Struct. We can choose a type, and then I guess the size of is because it can be any type. What size of the F key here?
So
Okay,
add object class filter.
say that again.
Was it using object what set object class filter or something?
I think the ones next along did. So let me just we have a Blackboard key, we know that much, and all that happens in the CPP is nothing. Okay, so we just know that we've got this struct which allows us to set the Blackboard keys, I think. Anything that extends that. So let's go back to look at our rotate to face a baby entry. Baby. Here we need to see how things are used. So position must come from these. I don't know if they're just U object. Okay, execute task. We still have those, right? Take task. We've seen those before. Get instance memory size of that's fine. Okay, let's look at the main bulk thing. Okay, so accept only actors and vectors. So we're saying, okay, you're allowed. Okay, that's what these filters are then. It's just for, to restrict what types you can select from the drop down. So if I went into here and we tried adding a task, the rotate, face this. When we go,
actor class.
Thank you for the follow, Peyton Rules. What did you ask, Brain?
So it adds an actor class there.
It's saying you're only able to choose between vectors and actors and rotators. So this is why it only shows self actor and target location. It's because they're vectors and an actor, whereas the bools don't count. So that's what the filters are doing, is just restricting what you can choose on our Blackboard key, which is the place where we set up our okay. Post-init properties. And what's the super? I want to see where this is. Is it U object? It is just a U object. Okay, let's not worry. This is like basically the immediate post-it. Is that also in U object? Yeah. Okay, so that's a bit much for us at the moment. Don't worry about that so much. I don't know why it's doing it in both. Same calculation in both. It's okay.
This is fast enough, you know.
Just in case. Anyway, okay. This is some mathsy stuff we don't need to worry about. Then our execute task. So this is our entry point. So the AI controller we can get from this owner comp. We can get AI out. So what is on this behavior tree component? That's something we care about here. It actually extends from the brain component. Not okay, that's good to know. And what members does it have? Oh wow, so this is like the whole behavior tree. This is, I think. So it's passing a reference to like what is running the whole thing, right? So we can know I think it is anyway. Finish late in execution. This seems like task related though as well. So we're just basically what I want to see is what it has access to. So it has this, the node memory. I think this is important. So we can get the node memory, which I think is the. I'm guessing that's the memory for this for a specific task, but instance index. I know you give it a node there as well, I guess. Okay. We'll have a look in the example in a sec, but I also just want to see. So we have our AI controller in here.
What is a node here? What do you think?
I think a task node.
So is a sequence a node as well?
Good question. Let's say no for now.
Or a service in a sequence even.
Let's just say tasks.
Okay.
You've got it's a very good question. I don't know the answer. Okay, where is the AI? What's the name of the function? AI owner. This is from the brain component, so one class up. So yeah, we're not looking to make a total sense of this. It's just to have a little skim through to see if we can pick up on anything. Okay.
Well, I hope we can make a total sense of it at some point.
Yeah. So okay, all we know is the owner though, and that's fine because the owner owns the blackboard that is running its logic. So that makes sense. So we have that. So we are able to, within this this execute function that we were looking at, execute task, we're able to get the owner, and then we basically fail if it's not valid, if the controller is not valid, or if the pawn is not valid. Then we turn our memory, the node memory coming in again. So if we just check this, they've made a struct. Yeah, so this is now going to get to what we have on this node, right? Big on. Oh, it's because I clicked on this. Sorry, my bad. So let's rotate here. Let's have a look at the code that compares to us. Focus actor set, and then focus location set. We have a bool. Structures are public by default, but they're not exposed to blueprint. So maybe we don't get to see that. All we have is this Blackboard key, and that is going to be the actor that we're passing in. I know that much, right? That's the bit that we know. So we have something that it'll say Blackboard key. I'm guessing the Blackboard key is what we've already looked at, right? That comes from that the parent class of this, which restricts what filters we're allowed. So that would be Blackboard key dot something, I think, when we get to it. Let's go back to that move. Okay, so we wipe the memory when we start it. Don't know why. We set our result to failed by default, and then I'm guessing we're gonna go through, and if we can, then it gets set to in progress if everything is right. What did you say? Sorry, Brian, I didn't hear you.
I don't understand why we're resetting the memory.
Nor me, because to me it seems the memory shouldn't exist between, but I don't know. Anyway. Okay, so now we get the pawn off of the controller. We get their location. Okay, Blackboard component here. We get the Blackboard component from them. Don't we that get passed in? We have the owner component, but not the Blackboard component. My Blackboard, where's that used? Here, down here. Okay. Because I thought that we could have probably got it off of this. The behavior tree. It's because each behavior tree has an associated Blackboard, but never mind. Well, no, we do, don't we? Owner comp, actually. Yeah, my bad. We do get that off of that. Sorry, completely my mistake there. So we just cache it for nicer use. That's fine. So we've now got that, and we want to get selected key type is equal to. So if it's an object, so you can either do it by object or vector, right? So that's fine because the Blackboard target, it's allowing you to do it. It's dynamic for both.
So it's satisfying both situations?
Yeah. It's just if you give it an object, this is how you're going to do your logic. If you give it a vector, then this is how you're going to do your logic. There's a rotator as well. I don't know how you rotate towards a rotator. Maybe it's just to try and match up your rotation. Maybe if you want to like get things facing in the same directions. So yeah, perhaps like flying geese. Okay.
Probably.
So this seems not too bad so far, actually. We check what type it is, and then to get it, we get the value. What's this then? Get the value. I remember you gave me this code before, if I remember correctly. Remember when I was doing it in AHA? Yeah. The tasks actually seem quite... They access it the same way as you'd access it anywhere else. If we just had our controller elsewhere instead of here, we're pretty much doing the same stuff. The only thing with this memory, I guess, we don't have. Is the memory used? Right. What? Okay, down here it's used. Okay, that's fine. So yeah, I think this is what allows it to keep coming back to it on the next tick, right? This memory, that's all it's used for. So it's stuff that we want to access in here. I'd imagine the node memory coming in then would be that memory. Oh, we don't actually use much in there. Okay, regardless. Let me follow this through a little bit more. So I want to read this line properly. We're getting a value. We know what type it is because of this. And we want to get selected key ID. How does it know? I guess this will be the name that you selected.
Yeah, that's what I thought.
Yeah, so this will be from whatever you've chosen from here. It'll get the name of it, right?
Mm-hmm.
So we don't have to type it in as a string. But okay, that's cool. We get the name of that, and then we cast it to an actor. What did we call this? Key value. Yeah, okay. So this will be, yeah, that makes sense. And then if the actor is legitimate, we do our maths to work out the difference between them. If we are facing it within the right amount of precision, then we have succeeded. If not, then we... that set focus thing. Did you see about that set focus before?
No.
So set focus, every AI controller has a focus parameter. And what's nice about that is if you set an AI controller to have a focus, you then don't need to cache. You can just say AI controller get focus to get a reference to that actor, if that makes sense. So it's a way for you to cache the, instead of having to store it in a Blackboard or something like that, you can just set your controller to be storing a reference to it and get hold of it that way as well.
Cool.
So we are setting it to this. Yeah, so we don't have to get this every time from here. We've set it and we can assume that the focus will remain the same thing then, right? Now this, I don't know. But I'm guessing if there's multiple things that want set the focus, it's a priority system. And then in our memory, we store it in memory anyway. That doesn't make sense to me. If we, pretty sure you. I'm pretty sure that we could do AI controller get focus as well. So I'm not too sure why we need to store it in here. But I guess we have to get this AI controller every time as well. So maybe it's easier. We don't need the AI controller each time. Okay, yeah. So in here then, so we store that active set, we set to true, and then we say we're in progress. That's it. That won't do anything else, and then it returns it's in progress. So I'm guessing it will then tick back in, right? When the global tick of the whole game application comes back to the behavior tree and says your time to tick. The behavior tree knows which node it's currently executing. It knows it's in progress, and so it will go ahead and come into this. So in here we then get the AI controller again anyway. Okay, so that's fine. It's really a shame, isn't it? Because you kind of want to do all this casting probably. Or maybe it's not casting. Okay, we make sure if somehow it's been destroyed, I guess this would be. But how would it be executing? Who knows? Anyway, otherwise, what's this now? The pawn direction that we're currently going in, and the focal point. Oh, this is interesting. Get focal point priority. So that means what you're trying to get to, I guess, because we've already set this, set focal point. Oh, so maybe focal point is different. Sorry, when I saw focal point, I thought that was hang on. No, there was focus. Ah, right, okay. So if you've got a specific location, you can set a focal point, I guess, instead. But okay, so they're saying.
And okay, so when you set focus, it automatically generates a focal point.
Probably.
Yeah.
Sounds about right. Focus, new focus information.
And if you use a vector 3 instead, f vector rather, instead, you can set it manually.
You know what's best when you write f vector 3. I do that still.
Yes.
Anyway, okay, so we're ticking through. We basically get where they want to. That's where the thing was, right? And then we calculate the difference between them. I guess if that's close enough.
Yes.
It's not rotating it though, right? In the tick.
No.
That's what I'm confused at the moment. Because that's it.
It's not rotating, no.
Oh, does this rotation keep rotating it then? Do we try? Hang on. Where do we rotate it? That's what I'm lacking at the moment. When do we change our facing?
I guess the
AI controller set focus might do it.
Yes, when you set focus, the character movement automatically rotates to that.
Yeah. Yeah, that's what I think. Hey, J-Dog. Yeah, I think it is dot product in there. That definitely seems to make sense. So if we go into the AI controller and we have a look at rotate.
See it in set focus, but using the focal point, it will rotate to that point eventually, right?
Update controller rotation here. So if it is a valid location and you, yeah, this looks about right. Then we try and rotate. Okay, so the task is making the most of another system basically, right? That's cool. We understand that task, I'd say. Let's have a look at the end of it, shall we? So we can wrap it up. Sorry, I didn't go through that many. So yeah, this is basically saying every tick you come in, check if the controllers are rotated it enough. And then, sorry, that's what's happening here. And if so, it cleans up. I don't know what sort of stuff would be in cleanup. Cleanup will just ask the memory again. Okay. Okay, so I think it's basically saying if it's still the focus of the task, then we're gonna clear the focus. Yeah, if nothing else has taken over that focus, that's what this is getting a bool for. And then if nothing else of that priority has taken over the focus on the controller, then we want to go ahead and clear it. But otherwise we wouldn't want to clear it if another enemy of the same priority has taken that focus. So
it compares the current one with the previous one.
Well, it compares our one with whatever the controller currently has. Not definitely previous. And
the previous we know, the last thing we know.
Right, yeah. Okay, fair. Yes, you're right. Okay, that makes sense too. So that's that cleanup. We don't have to do anything special like wiping the memory. It's more of just like make sure we don't anything that we interacted with in our main body we now are trying to undo if needed. Abort task. I don't know how abort task gets called, but that could be the interruptions, right? I guess. Those notification things, right? Okay, so here. Okay, so we just clear up and we'll return that. That's fine. Describe runtime values. I think you have to implement this. It's a virtual, pure virtual perhaps, but think this is if you hover over it at runtime, what info you get out. When we did our task wait, let's have a look how it did the describe. Yeah, when I hovered over the wait thing, it came up with remaining earlier. So yeah, I think that's all it does. It's a way of conveying information. That okay, and then yeah, whatever with these. I guess these are less important. Okay, I feel that wasn't too bad.
No.
I like that we ended up just looking at an existing one instead of finding some tutorial, which is that's a very adult step for me to do that. I like to be told how to do ship instead of finding it. So yeah, that's a positive. Is EBT node to do with pathing? I don't know what EBT node is. Was that in here?
I think it's in Behaviour Tree node.
Ah, sorry, I see now. So yeah, this is just the thing that the different ways that a task can end. In progress, it will mean the behavior tree stays there. Aborted is if it gets interrupted by something other than the current task it's in. Failed is yeah, succeed. Cool. All right, that was useful. That was useful.
I'll stop here.
Yeah, I'm stopping as well. I didn't plan to go 3 hours, but yeah, no, it's been good. It's been straining, and it's late for you as well. What's the time difference with us at the moment? Is it almost 11 for you?
Yes.
Yes. Okay. Well, thank you for joining, Brain. Thanks for coming through this. It helped having someone else to say yes or no or whatever with me.
Yeah, most to say yes.
Not to get lost in the rabbit hole. Yeah, you have a wonderful night, and I'll catch you on the weekend probably.
You too. Bye-bye, man.
Thank you, mate.
Okay.
Bye-bye. Okay. So, yeah, I think we hit a good point. So, we what we did here was we looked into code-based task to understand its implementation, I guess. So, what did we look in? We looked into rotate to face EB entry and wait is what we looked at. Okay. I'm gonna see if there's anyone for us to raid. My throat is hurting. It's getting a bit late for me as well. We've done a good 2.5 to 3 hours, and I'm happy with that. We'll be back on Sunday to continue this. Yeah, I'm looking forward to it. I enjoy this stuff. I like one of the things I often see when I've done game jams, especially I've done a few game jams with Brainoid, right? And he's always the one who does any AI in it. And so I always feel like that's never really an area that I've worked in. And so I feel a bit crap at it, to be honest with you. Like, even if I was just doing a platformer, I feel like, how do I just make an enemy that does a little patrol? And I'd imagine, yeah, you give it 2 points per enemy and you say you patrol between these. That would be simple enough. But then when you say, okay, but if you get closer to an enemy, then you start running faster towards it. It's like, well, you can do that via code, but like, how do you do that check? Do you just do a sphere cast around you? And if the player's in it, how often do you do that sphere cast? How does it return to its normal control after running? And then it's a case of then looking at behavior trees as well. And behavior trees is just like an approach to applying the AI logic. You don't have to use them. You can achieve the same thing without them. But when it comes to more complex things, I feel the behavior tree has been set up in a way that will allow you, and it's proven as a method, it's not a UE4 thing, it's a general thing, right? It's proven as a method to simulate a bunch of behaviors with fallback behaviors, randomness, and different choices, a branching decision making for the AI to do and to exhibit behavior that looks a bit more organic, right? And is reactive to the environment. But yeah, I'm looking forward to finishing this month. I don't want to rush through it. I mean, I'm looking forward to learning more this month.